Yeah, what's going on, everybody? It's Lyrical. I mean, you know that already. You already know. I hate when people say you already know, because like the majority of people that are ever going to watch your videos, they don't know. They have no idea who you are or anything like that. But I'm just chilling out in the park doing lunchtime with Lyrical, and already ate my lunch though, so that's gone. So you really don't get to see the lunch. But there's a couple people now, stepping into the little park here that we got. So I'm going to try to make this fast. I've been talking about conspiracy theory, we're talking about UFOs, put this on my page, and I realize the numbers can lose people, so I just kind of wanted to say it in a way that that wouldn't lose as many people. In fact, let's go on a walk. All right, so I'm gonna take you down here. We'll go back to my little waterfall spot, and let's talk about this. So turned out yesterday that the blimp was not a spaceship, obviously, right? People thought there was a UFO, right? It wasn't a UFO. It was a blimp, and that's kind of to be expected because the probability of us ever finding the spaceship, let alone extraterrestrial life, is pretty incredibly slim. So if you're out there with your picture almost willing to die off the side of the highway, you probably might want to let somebody else get those pictures unless you're just trying to boost up your social media, because it isn't going to really probably happen. And here's why, right? So let's just, and I'm not, I know I'm a mathematician, whatever, but I do basic math all the time. I don't try to do the fancy stuff too much, right? At least speak about it, because it loses people, and I know this can lose people too, at least in print, so I'm going to say it kind of easily, right? The sun is 93 million miles away. So if the sun is 93 million miles away, and we think that's the closest star, right, that's keeping everything hot, right, which we usually need for the biological life that we have on, at least on this planet, we have to kind of think like, where would the next one be? Because I think, it's probably a slim chance that there's any kind of intelligent life like we are in our solar system, right? So you got to look to the next star system away. Alpha Centauri is like a triple star system, and it has 3 stars and a couple planets that may have a chance at having intelligent life on it. So if it did, though, the problem is we'd have to get 4 light years away, right? There's another one that's been in the news quite a bit for years now that people are talking about it in 20 light years away, right? If we were to get there, it seems like there's a planet that would have, well, maybe it exists, maybe it doesn't. It seems like it would have the climate environment that would be hospitable for life similar to our planet, right? So that's super exciting. You got to find those in the Goldilocks zone where it's not too warm, not too cold, to give us a fighting chance, right, of there actually being life there. So that's what we're looking for. But 93 million miles away, let's just put it like this, right? The sun is 93 million miles away. That's 8 light minutes. It takes 8 minutes for that light to get here. But then you think, how many times does 8 minutes go into just a day? And the 60 minutes in an hour, 24 hours in a day, 60 times 24 is 1440. So divide 8 into 1440. It's a nice round number. It's 180. So it's 180 times further than the sun if you just send something at light speed for 1 day, right? Let alone 4 years. That's what 4 light years away means. You turn on a flashlight, which goes at the speed of light, it would take it 4 years for that beam of light to reach the other side. And that sounds like, okay, whatever, but you got to kind of model it in perspectives that make sense, right? There's a famous grapefruit example. It says if the sun was the size of a grapefruit and you were to try to get to another grapefruit-sized sun, right, like the one that would be 4 light years away, we can do some math to sort of put that on scale. It'd be essentially like going from the East Coast to the West Coast, something like 2,500 miles, right, if it was the size of a grapefruit. That's something you can visualize. But let's even stay with the light years kind of stuff, right? Let's just use a round number. It's not exact, but let's just say 180,000 miles per second. That's the speed of light, okay? It's a little more than that, but just use the round numbers, 180,000 miles per second. Most of the scientific world speaks in meters, so I'm going to keep it in miles per second for my general audience here, okay? So that's miles per second. That's how far it gets in a second. Yo, 180,000 miles in a second? What? Okay, so follow with it. We said there's 1,440 minutes in a day. So that's 180 times farther than the sun that beam of light or something going the speed of light would get in a day. And now you got to multiply that by 365. And that's in the 65,000 times further away range. That's just for 1 light year. 1 light year, right? You multiply it by 20 to get to the one that might have life like ours, that it seems to be a good bet if that planet exists, right? What's that, 1.3 million times further? You know what I'm saying? That's just insane. 1.3 million times the distance of the sun, right? I mean, yeah, it'd be closer if we're going 4 light years as opposed, but I mean, it's only 5 times closer. You know what I'm saying? So divide that by 5. And yeah, we can do, there's some clever ways we can approach light speed too. That's the other thing. Like our spacecrafts go like 20,000 miles per hour. Imagine if we get the technology to double that on average, right? And get it up to like 40,000. I mean, we're only cutting the trip in half, right? So, as opposed to our 20,000 mile per hour trip that we'd have to go right now with what we're using. It would take forever going 20,000 miles per hour, because you got to think, how many times does 20,000 miles per hour go into something that goes, oh, by the way, 180,000 miles per second or so is in the neighborhood of 600 million miles per hour, right? So to get something up in that 600 million mile plus hour range, and you're only going 20,000 miles right now, you can think about 20,000 goes into 105 times, right? So that's 100,000. You gotta do that 10 more times. So 50 times slower just to get it up to a million, right? So I don't want to lose y'all with the numbers or whatever, but just trying to give you a picture for how crazy low the probability is that something could make it that far in our lifetimes, or in, you know, lifetimes, right? Unless it's something small, maybe the size of a phone. And there's technology out there that, you know, people are thinking about and trying to come up with clever ways. Like you can move something smaller closer to the speed of light than you can something big, right? And that's the other thing too. A lot of these times we get these false positives with these UFOs or UAVs, the unidentified, you know, aerial phenomenon, UAP, sorry, unidentified aerial phenomenons, right? That's like other countries will refer to them as China will. China has, by the way, an object that looks like a helicopter. They call it a helicopter, but it's the shape of basically a UFO. So a lot of times when we're seeing these things, it's false positives, just like the blimp, you know, in New Jersey that wasn't a UFO, or you know, I know the pilots saw an unidentified flying object, or a UAP as well, that the government finally, you know, declassified and we're like admitted to, yeah, we don't know what it was. But a lot of times it's war games, it's things that even our own government's working on that we don't know about, other governments. Or maybe, yeah, it could be that UFO. And if it is a UFO, it's probably unmanned or unthinged, whatever you want to call it, right? It's very far away. Unless they have hibernating technologies like you see in some of these space movies, or they figured out space-time, you know, folding and wormholes and that kind of stuff. The stuff of a lot of science fiction movies, right? That people are thinking about mathematically and scientifically, is this something that can possibly happen? So the fun part is teach your kids interest in STEM, let them watch sci-fi, let them think, let them dream, let them work on these problems that'll help us know and help us advance our species, right? It's all good stuff. Without the science and math, you can't do it. You can't even begin to think about what you don't know until you can put these terms like the grapefruits, right, in sort of an everyday kind of perspective that you can think about, and then really wrestle with the problem. Because only when we know the problem that we're faced up with can we really be creative, right? So that's it. I'm out. If you see those aliens, you know, let me know. But I'm guessing you probably won't.